All right, we're going to continue on with curves. We're still naming parts. We've got the couple of parts we need to go over. First one is the external ordinate. This is the ordinate. That's the abscissa, or otherwise known as the long chord. Anyway, on this ordinate are a few parts. The external ordinate is the distance between the curve, the arc, and the PI. And the middle ordinate is the distance between the midpoint of the long chord and the midpoint of the arc. Now, why do you need to know that? Well, other than just making your life miserable with calculations, there's a reason for it. If you are able to set up on the PI, get a tape measure out there, and you measure back towards the radius point, and you measure whatever that external ordinate distance is here, in which case it is 366.48 feet, and I'll show you why in a minute. Then if you can measure that on that bearing, you have just located the midpoint of that curve. And since this is a 1,200 foot radius curve, you just did a bunch of work right there, because you can set a point there and the man with the bulldozer can start there and clear a path. You can do the same thing if you can't get on the PI. You can, if you know where the PC and the PT are, and you have a line of sight between the two of those and can hit the midpoint of that and can look towards the PI, either with an instrument or a compass or something like that, and you can calculate the mid-ordinate distance, which in this case is 280.75 feet, and we'll get into that in a little bit. All you have to do is stretch tape from that midpoint in that direction, that distance, and you have staked the middle point of the curve. It's a great way to check your field work if you have the opportunity. So anyway, we have defined the external ordinate and the middle ordinate. Now, there's a bunch of ways that you can calculate for it, and I've given you on this lovely little sheet here a couple of them. The external ordinate is r times the secant of delta over 2 minus r. What on earth is a secant? Well, it is the inverse of the cosine. And it's called a secant because this long chord intersects the circle at 2 points. That's the definition of a secant. So in any event, that's one way to calculate it. The other way is to say that the external ordinate is equal to the long ordinate, O, minus the radius. Another way to check. The one that's a little bit harder to do is the mid-ordinate. And you basically you know the radius, which in this case is 1,200, and the cosine of delta. Delta in this case is 80, so the cosine of delta over 2 is, I'd have to calculate that. Anyway, you get the cosine of delta over 2, subtract that from 1, and multiply that by the radius, and you come up with 280.75 feet. So that's a quick explanation of what these two figures are, why you use them, why you should be able to calculate for them, and we're going to go on with radians in the next section. Radians are what allow you to do the real work on staking the curve, and I'm going to give you a preview of that. A radian is simply another way to measure an angle, and it's 180 degrees divided by pi. That's all 1 radian is. And it equals about 57 degrees and change. Going to show you how to do that on your calculator, and we'll be back to do the next section, section 4. So do the exercise 3 and get that done, and then we'll go on into the radian section.